For a while, I've wondered if it's possible to train a model on a Raspberry Pi 5 and then to take pictures and run inference, and all with Python from scratch, and it's possible. Last week I showed you a video of training the model, and this week I'll show you how to take pictures and test the accuracy. We're using the Raspberry Pi version 1.3 camera. This is like a 5 megapixel camera, and what we have to do is downsample it to 28 by 28, grayscale it, and invert it. Most of MNIST sample sets are inverted, and let's get to it. Here's the result of taking the picture of the 0 with the pi here, and mostly zeros. This value here is 0, but as I go over, you'll see 178, so on and so forth. So we're getting good looking data, in my opinion, here. So here's the result in picture format. This is also saved as a few different CSVs. So first we'll go to this one. You can clearly see this is a 0 here. The ultimate format we want, though, for inference is to have a flattened format. So instead of having 28 by 28 rows and columns, we have one row and 784 columns, which is 28 squared, to more or less match the MNIST test CSV test data. Each of these numbers is about an inch tall, and I'm using this fat Sharpie marker here. When I take the pictures with the Raspberry Pi camera here, it's like a couple inches away, and I try to fill up most of the camera shot with the digit. Notice I have this lamp here. The lighting's really important, but I don't have like a ring light or anything like that for this situation. But it works pretty well. I also have a filter here, so if the pixels are less than 75, then it just equals 0. I'll show you how this works. So I go to this program here, run, and the camera is loading, and there we go. If you want to try this yourself, go for it. Go to this Pi camera data and data collection folder, and then copy this program here down at the bottom. Take pic inverted 0 to 255. You can see some sample data here. So this was taken with the Raspberry Pi and Pi camera. In this folder here, I've created this file, mnistcam.csv, and this has all the collected rows of cam data pictures. So this is digit 0 through digit 9, and then this is so these are labels. This is the header, and then there's 10 rows, one for each digit. And then this is 784 by 1 row by 784 columns, comma separated. This file here, take this, load model applied to mnistcam.py, and run it. This will show the weights and biases. Notice here that I'm bringing in the 94 CSV values here. So this is what the weights 0 through 9 look like. And we were getting 94% accuracy, but that was with the nice looking data that initially we downloaded. But the camera data, let's see what that turns out to be. What's the accuracy? So then, go back to Thani. We go down here to the end. Copy these 2 lines. Paste in the shell. Delete this comment. Go down here, and there's our answer. 70% accuracy. And it compares. So 7 to 7, that's correct. 8 to 3, that's incorrect. 5 to 5, that's correct. 4 to 4, that's correct. 2 to 2, that's correct. 1 to 1, that's correct. 0 to 0, correct. And then 3 to 9, incorrect. 8 to 6, incorrect. So there you have it. We have our accuracy here. Thank you for watching. I thought this was a pretty interesting project. All the links will be in the description, and feel free to try it at home. Make sure when you do try it, all the loaded CSV files, they're in the same folder as the program that you run, and give it a shot. Alright, take care everybody.